The first question I'm going to be doing is question 3 from the problem set. And it says, determine the domain and range of the following functions. There is no graph. Okay? There is no graph for you to play with. There is just an equation. If you had a graph, I think most of you would know exactly how to answer this about domain and range. And remind you, domain is what are all the possible x values. Range, what are all the possible y values. So let me just sort of go back to basics here. This is obviously the equation of a what? What kind of function is this? We had a bunch of functions that we started off with, yes? It's a linear function. It's a straight line function. Your y equals mx plus b type function. When I asked the question earlier on, Amira said that it was a straight line, which means that it looks something like this. Whoa. Sorry. Which means it looks something like this. Maybe it's 5. So maybe it's a negative 5x plus, maybe something like that. But we didn't have the picture. But the question is, if it was just any other straight line, what would be the domain and range of a typical straight line? Yes. XCR, YER. So a typical straight line would just be this. XCR, YER. Let me say this to you. There is something you're going to be learning in advanced functions. I'm going to assume a lot of you are going to go on to advanced functions. Anything which is what's called a polynomial like this, which is like a straight line, the domain and range is always going to be all real numbers. So that's my little clue to you. If I give that to you on the problem set and it's just a regular straight line, if there were no restrictions on the original line, then it means that this will have no restrictions either. So for a straight line, we don't have to do anything but just simply say that because it's a straight line, it's XCR There's one exception to that, which I will give you in a minute. So the answer to the question is, actually, I should write them separately, domain and range. So let me write the word domain first. And that would be x is all real numbers. And then write the word range next. And then write that y is all real numbers. So for a typical straight line, even if I didn't draw it, it's going to be all real numbers. Let me give you the exceptions. There's 2 exceptions. So let me give you the exceptions. If their equation is for exceptions, that's not how you spell it. So here are the 2 exceptions. I'm going to use a red line to represent my exceptions. Perfectly horizontal line. Right? Let's say this perfectly horizontal line was the line y equals 6. Horizontal lines have equations that look like that. So all the y's along here are y equals 6. What is the domain and range of this? Right? Okay, let me start with the domain. What's the domain? It's XCR. But what's the range? What is the range of this flat line? He's right. It's all real numbers. It goes to forever to the right, forever to the left. So the domain is all real numbers. But what's the range? Yes. Not quite. You want to be putting away the phone right now, not focusing on the phone. All right. Maybe you want to put that on the desk face down or something like that, so you don't get distracted by that. Let me hear what Ashton thinks. That's it. And I suspect that all the other hands that went up were going to tell me the same thing. There is only one value of y. Y is always 6. So the range of this function is that y is equal to 6. There's nothing else. There's nothing above it. There's nothing below it. It's just 6. The domain is what Suchir said. The domain is all real numbers. Okay. What about if it was a perfectly vertical line? Let's say that the equation of this line was x equals 4. So here are the exceptions. What's the domain and range of this? What's the domain, first of all? What's the domain? Okay, yes. Shay. X equals 4. That's your domain. So it is a straight line, but it doesn't follow the normal rules of a straight line. So the domain is x equals 4. What about the range of this function? Yes, it's YER. And by the way, for the one before, the domain was XER. So the only one exception to a straight line is when you say perfectly horizontal line or perfectly vertical line. So I may throw that at you on the assignment. Yes, Masumi. YER especially because it's not all real numbers, it's just one number. You'd only put that, yes, if it's only one value, then there's no point putting YER because YER means it's all real numbers, right? Usually it says all we know is X, but it can't be this. Well, we're saying it's only this. So there's no point that it's saying it's anything else. It's only this. That's a great question, Masumi, by the way. Normally we'd put, even if we put Y is equal to 6, we'd say like, YER. Well, it's not really YER, it's just 6. That's it. That's the whole domain, or sorry, whole range in this case. So that's a great question. Thank you very much for that question. Okay, the first one was easy then, right? Let's get to the second one. Things are going to be a little different with the second one. This one is a square root function. The square root of minus x plus 2 and then minus 3. Now, let's put this in generic terms, right? Meaning the f of minus x plus 2, kind of like what you're doing yesterday, minus 3. That's in generic terms. I could apply to any function. We're going to apply to this function here, though. Tell me what's going on when I'm doing minus x plus 2. What kind of transformations would I say is going on when I'm doing this? So whether I'm going to do the generic or I'm doing specific when it comes to a square root function, give me a list of transformations that are going on right now. Yes, Rosie? Reflection on the y is one. But I'm going to tell you something, Rosie. You're right. One of the things that I'd want you to do with this first is to make it look a little different. Can anybody tell me what that means? Why should this be a little different? Just to make sure I don't make any mistakes. Yes, go ahead, Manhill. Factor out the negative 1. It's not going to change the answer I just got from Rosie. That answer still stands. So I'm going to make this minus x minus 2. And then the minus 3 on the end there. These are equivalent, but this makes it more obvious what's actually going on. So yes, go ahead, please. This is not an equation. This is just another way of writing the general equation for this transformation. So it's not really an equation per se. It's just a way of representing the transformations. That's really all it is. So can we get a list of transformations that are going on with this then? Let's use this one. Give me a list, please. Okay, go ahead, please. So VT down 3, you said? Perfect. Thank you, Sahil. VT down 3. What else? Thanks. Go ahead, AJ. Can't hear you. HT right 3, right 2. Yep, HT right 2. Anything else going on? Or is that it? Because I think there is something. Oh, actually, you know what? Rosie actually told us at the beginning. Okay, so let's not ignore that. Rosie said, one second. Rosie said that this was a reflection on the y-axis. That's what that negative in the front. So let's just acknowledge that first of all. I'm going to take AJ's question after that. So reflection, I don't know why I'm putting a negative there. Reflection on the y. Axis. Okay, sorry, AJ, you had a question. I would suggest you do it because if you don't, you might factoring out the thing in front of the x may make you not realize what the actual horizontal translation is. So I think it's a good idea to factor it out. If that had been negative 2x, for instance, that would have affected how much the translation was. Okay? So I think it's a good idea to do it. Now, before I go any further, let's talk about what each of these things affects. This VT is going to affect either the X or the Y. I need to know which one. Let me go back there. Charmine, what do you say? It affects the Y. I put that in red in a bracket. The HT right by 4. What does that affect? The HT right by 4. Okay, hold on. Wanya, what do you want? Right by 2, sorry. Wanya, you're going to tell us what? It affects the X. The reflection on the x-axis, on the on the y-axis, Triash, it affects the x. Surprisingly, affects the x. Now, here's what there are two things I need to teach you about so that we can get this right. We need to talk about the domain and range. That's our goal here. What's the domain? What's the range? One of the things I need to teach you is that when you are, well, before I teach you that, let's just go back to what would a typical square root function's domain and range be. Let me remind you what a square root function looks like on a graph. So if it's just a regular square root of x function, it would look something like that. That's your typical square root of x function, right? We've seen that before, we know what that looks like. Sorry, you had a question. Go, tell me. And what about the range? Same thing. Yeah, same thing. Here's my arrow, by the way. No arrow on the other side. There's no arrow on this side, only on this side. So the domain, normally, this is before we do any transformations, the domain would be x is greater than or equal to 0 or equal to 0. The range is y is greater than or equal to 0. Okay? Yes, Jay. You should. Yes, absolutely. Thank you very much for bringing that up. That's what Masoon was asking about earlier on. So let me do that. Che is great at spotting when I leave something out. So x is greater than 0, xer. Y is greater than 0, yer. So it can be any real number as long as it's greater than or equal to 0. Good point. Now, I need to take a little bit of a detour. Right? You're going along the road and you get to a point where you have to take a little shift to the right, shift to the left, just to make sure you get to your destination. I'm going to do a little detour right now. Right? There's something I need to teach you about inequalities because this is an inequality. X is greater than 0 is an inequality. An inequality is something which is either greater than or less than, or greater than or equal to, or less than or equal to. And we're dealing with that for this. So there's something we need to know about inequalities. Inequalities are treated just like equations, except in one instance. Let me write down an inequality on the board and show you what that is. Are you listening over there or are you texting on the phone? Which one? I just need to know which one you want to do. All right, let's just stick with this for now. You'll have time for that later on. Okay, so if I gave you an inequality such as x plus 5 is greater than or equal to 9, right? That looks a lot like an equation. In fact, it even has an equal sign in it. How would I solve it? Exactly what you think, which is I'm going to go ahead and take 5 from two sides of the equation. If x plus 5 is, so I'm going to write solving inequalities on top here. Solving, you'll see why I'm doing this in a minute. Inequalities. So if x plus 5 is greater than or equal to 9, that means that x plus 5 is greater than or equal to, oh, sorry. Get rid of this. That means that x is greater than or equal to 4. Done. I just solved the inequality. Just like I'd solve a regular equation, like you did in grade 9. I just take 5 from the two sides. This is a 9. It doesn't even look like a 9 to me. So I'm kind of wondering what it looks like to you. Just taking 5 from the two sides and solving like a regular equation. All right? So I didn't teach you anything there a while ago. Nothing. Nothing was new from what I just did. If it was that 3x is less than, I'm not going to put less than or equal, I'm just going to put less than, is less than 12, then what do? Divide the two sides by 3. So therefore, x is less than 4. So far, nothing new. You knew all of this from before. Here's what's new. And this is going to apply to what we're about to do. If this had been minus 2x is, let's say, greater than or equal to 10, yes, I have to divide the two sides by the minus 2, right? That's what we do? Is that how we did it back in grade 9? We divided two sides by minus 2, right? Okay, so we're going to do that. We're going to divide the two sides of the equation by minus 2, but this side is going to become minus 5. This side is still my x on its own. Does everybody know what's about to happen? Can anybody guess what's about to happen? Yes, the chair. You flip the inequality. That's exactly right. So whenever you have to divide both sides by a negative or multiply by a negative, either one, the direction of the inequality flips. So instead of x being greater than or equal to minus 5, it's less than or equal to minus 5. That's the answer to this inequality. I'll do one more just to make sure this is we all understand this. Let's say minus x minus 6 is equal to 4. I just made that up. Totally just made that. Not equal to. Greater than or equal to. Sorry. Minus x minus 6 is greater than or equal to 4. So first things first is what? What's my next step in solving this? Help me out here. What's my next step in solving this? AJ? Add minus 6 or add 6? Add 6 to the two sides. Okay, good. So I'll do that. I'm not changing direction in inequality because I'm adding 6. Adding or subtracting does not change direction in inequality. So minus x is greater than or equal to 4 plus 6. So minus x is greater than or equal to 10. Yes. Now we're going to divide by minus 1 to get that x on its own, as Manuel just said. So that means that x is now less than or equal to minus 10. Okay? We're going to see why we're doing all of this in a second. Why we're solving inequalities is important for us to understand. So let's get back to the question now. We said for this particular type of function, a square root function, that the domain and range were x greater than or equal to 0, y greater than or equal to 0. That's domain and range. Those are inequalities. So we're going to have to do something to the x and something to the y. One affects the domain, one affects the range. Let's talk about the domain first. The domain of the function is x is greater than 0. The current domain is x is greater than 0. If you have ht right by 2, that affects the x, and a reflection on the y-axis, which one comes first again? I forget which one comes first. Which one do we have to do first? Yes, Masumi. The reflection comes first. So if the reflection was that x is greater than or equal to 0 for the domain, let me scroll down. So we're done with inequalities now. So the domain used to be x is greater than or equal to 0, but there's a reflection, which means essentially I'm multiplying by minus 1 or dividing by minus 1. What happens to my inequality then? If I am, and by the way, I'm going to do something else. Something else affects the x. Something else affects the x. The other thing that affects the x is the reflection, sorry, is where is it? HT right by 2, right? So we're going to do that as well. But Masumi said we have to do the reflection first. So if we have to do the reflection first, what do we do with this original? So here's the original. Its x is greater than or equal to 0. What's going to happen to that? What's going to happen to that inequality? Okay, Manahil, go ahead. We good. Now, even though it is 0, and you're going to say, but it's still going to be 0. Yeah, but the inequality still has to change direction. So, because of the reflection, so reflection leads to this becoming x is now less than or equal to 0 instead of greater than or equal to 0. But we have to do something else. So that takes care of the reflection. Now we have to deal with what other thing affects the x again? Let me scroll back up. Let me scroll back up. What else affects the x again? Anybody? Tell me something else that affects the x. Come on. Yes, Triash. And how does it affect the x? You add 2. So x is not just less than 0. So this is for the horizontal translation now. That's going to mean you're going to have x is less than or equal to 0 plus 2. Or 0, let's put 0 plus 2 to make it obvious. Which of course means x is less than or equal to 2. Okay? Because we're adding, because of the horizontal translation to the right by 2. That is our domain, our new domain. Right? We didn't have the graph. We can go to the graph in a second, and we will. But for right now, we didn't need the graph to do this. We had to have an idea of what the domain and range of a square root function was. And we're going to adjust that domain and range based on the transformations that are going on. And that takes us to this. So there's our new domain. This is the domain. Let's get to range. So the domain part of it is this. Let's get to the range part of this now. Now my range used to be y is greater than or equal to 0. That's what you told me at the very beginning when we were doing this. The range was y is greater than or equal to 0. By the way, yes, before Che reminds me, it's not just this, it's x is all real numbers. But let's get to the range. And the range used to be y is greater than 0 or equal to 0. What should this do? This y that we said, the thing that affects the y was vt down 3. Vt down 3. So how is that going to affect my range is the question. Does anybody have an idea? Yes, Ashton. You take away 3 from the 0. Absolutely. So now we're going to say that the range is 0 minus 3. So this is as a result of the vt down by 3. So this becomes y is less than or equal to 0 minus 3, or y is less than or equal to minus 3. And yes, yer. Okay, so there's your domain and range. Yes, Masumi? Why did I flip it? Okay, because of the reflection. When you normally have a reflection, you multiply or divide by -1, right? You change it, or you change the sign because of the reflection of the y. And that's why our range affects the x. Affects the x. Oh, good question. Yes, this should not be switched. Sorry. So just like Che, Masumi has caught me. This is wrong. That was wrong. And I'm assuming other people would have picked that up as well. Right? You're not changing direction on this one at all. That's a good catch. Thank you very much. We change the direction on the x's because of the reflection on the y, which causes the x's to change direction. But that's not the case for this. Okay? Look at this one. Tell me what kind of, okay, Che, what is this? It's a quadratic function. Quadratic function. So under normal circumstances, What would be the domain and range? I'll draw you one just to help you out. Here's my typical quadratic. Okay, so it's not great, but there's my typical quadratic. Under normal circumstances, what's the domain and range of that quadratic? Right, just a regular y equals x squared line. Yes, Abel? The domain is XCR. Let me write that down. So normally the domain is XCR. How about the range for a typical quadratic function? Yes, Ashton? Correct. And then you say YER. All right, that looks very crabby, but anyway, let's move on. Now, give me a list, please, of all of the transformations. Gary, help me out, please. Give me a list of all the transformations you see going on with this function. F of x or y equals 4x minus 5 squared plus 2. Give me a list of the transformations, please. Good. VS, BAFO4. Okay, what else? HT right 5. Thank you very much. Anything apart from Gauri? Anybody can give me the next? Yes, Yash. VT up 2. Well done. You guys really are picking up on this transformation stuff. Okay, that's good. Now, let's put beside each of these what's being affected. Is it the range or the domain that's being affected? The VS. Let me go to the back of the room and ask Angeli that question. The VS affects what again, Angeli? The y-axis, correct. Put that in red. The HT, what does that affect again? Let me come in the front here, Athuzan. What's that? Affects the x-axis. And the VT, what does that affect again, Aria? The y's. Anything vertical is y, anything horizontal is x. Well done. Okay. Now, my original domain was, it was all, let's talk about domain. So we're going to focus on the HT right by 5, which is the one that affects the x. So the domain used to be all real numbers. We're going to add 5 to that. Well, if it's every single real number, and we add 5 to the all real numbers, what are we going to have as our domain? Right? It used to be all real numbers. We're going to add 5 to that. So where are we going to get? Where are we going to end up? Help me out, folks. Yes, Che. It's just XCR. It's all real numbers still. So the domain has not changed. So the domain of this function, adding 5 to that, adding 4 to that, which is the, sorry. What am I talking about here? It's the x values. Adding 5 to that, which is the HT, is not changing anything. It was XCR before, it's still XCR now. Okay. How about the range now? The range affects the y. So, the range used to be y is greater than or equal to 0. What are we going to do with that 0? Yes. What about the vertical stretch by a factor of 4? That's not going to do anything? It's not. It's not. Multiplying by 4 doesn't do anything. 4 times 0 is still 0. But we have to do that first, though. We have to do the vertical stretch first. Right? That's in terms of getting in right order. But 4 times 0 is still 0. But then we have to add the 2 after that. So that means it's going to become 4 times 0 plus 2, which of course is just simply equal to 2. So now instead of being that y is greater than 0, it's now y is greater than or equal to 2. That's your new range. And again, I'm not going to draw that graph this time. You can do that on your own time. That would be basically the graph is just being shifted to the right by 2. It's been it's been stretched as well. It's been horizontally translated, but horizontally translating it left or right does not affect the domain. It really doesn't. It's still all real numbers. So there we are, folks. That one is done. That one is done. Yes, Yash. Yes, yes, yes. That's a very good point. Since I'd be taking marks off for you, I need to take marks off for myself when I forget to put that on there. Yes. Because the original the range was y is greater than 0. So we're trying to see what to do with that 0. Multiply it by 4 and then add the 2 because of the VT up by. See, these are things that affect the Y, the VT and the B and the VS. Okay? When you're talking range, you're focusing on the Y's. Make sense? Remember, domain is my X's, range is my Y's. My domain used to be all real numbers. That's not going to change anything. Adding 4 to it, it doesn't change anything. The range, though, had an actual number. So we're going to take that number, we're going to do stuff with it. We're going to, first of all, multiply 4 because of the vertical stretch, right? Times it by 4, but that doesn't change it a 0. 0 is still 0. Then we're going to add 2. Well, 0 plus 2 is still 2. Okay? So that's why it's now x is greater than or equal to 2. Okay? Whoa. I'm going to make this one easy for you. I'm going to make this one easy for you. First of all, what kind of function are we dealing with this time, right? What was the base function that caused us to end up with this function? All right, look back at all the functions that we've been looking at. What was the base function on this one? Yes, Gary? Cubic function. Let me draw your cubic function and ask you for the domain and range. I think I can use this. A cubic function looks like this. Just reminding you, that's what a cubic function looks like. Okay, that's before the transformations. What is the domain and range of that cubic function? Naomi, what do you think? Help me out, please. Look at that picture that I just drew. What would be the domain and range of that? Domain first of all, and range next. Help me out. Domain, please. It's XCR. And the range. Sorry? It's all real numbers as well. No. In general, just like a straight line, if your domain and your range were unrestricted, I don't care what you do to the function, it's also going to be the same domain and range. So I'm going to make this one easy for you. No, the straight line had some exceptions. This one doesn't have any exceptions, right? A cubic function, which looks like this with an unrestricted domain and unrestricted range, you could rotate it. Well, we don't have none in rotations. We could reflect it. We could horizontally compress it. We could reflect it. We can, whatever you like. It's still going to have the same domain and range. FYI, for cubic functions. So just like linear functions, this one is unaffected by the transformations in terms of domain and range. It's going to move it, left, move it right, compress it, reflect. You can do all that stuff with it. The answer to the question is that no change. To the domain or the range. So we can just bat this one out to the park and move on. I see a hand going up. Yes. Sure. If there was no restriction on the original domain and range, when I asked the question earlier, Naomi said that this cubic, it's a cubic function, by the way, right? This cubic function has an unrestricted domain and an unrestricted range. Case closed. That means our job to figure out domain and range after transformations is over, right? If there were no restrictions on the original function, there are no restrictions on the transform function. No, I did make an exception, as I said, for linear functions. Even though linear functions have no restrictions on the range and no restrictions on the domain, there are two exceptions to the rule. If it's a perfectly flat line or a perfectly vertical line, then there would be a restriction on the range or domain. But apart from that, functions like these, with no restriction on the original, there's no restriction on the. Does that help? Okay, good. All right. Whoa. This is the last one for this question. What kind of function are we talking about this time? Charmaine says what? What's that? Absolute value. So I'll remind you what that looks like. Thank you, Charmaine. It looks something like a V shape, like that. V shape. Can somebody now give me the domain? And let me come in the front of the room here, Sahil. Give me a domain and range for something looking like that red graph. Keep going. Greater than or equal to 0. Yeah. Okay. All right. So originally, so for this one, the domain is XCR right now. And the range, without me doing anything, is YER. Sorry, Y is greater than or equal to 0, but YER. Okay? One day I learned to write. That looks terrible, I know. All right, so we know what the domain and range are for before you did anything. Let's talk about all the transformations that are represented by this. Okay? Let me go to Jasmitha on this one. Jasmitha, can you help me out, please? Give me all the stuff that's going on with this. Give me all the transformations going on with this, please. VT down 1, okay. Give me another one. HT right 5, good. All right, thank you very much. Let me go to Atifa. Go ahead, give me 2 more, please. You're on the right track, but you said one thing I didn't like. AJ, what's that? A compression? No, it's not a compression. No. Yes. Vertical, sorry? It's not a compression, though. There's one thing you said I didn't quite like, though. Um, Aaron, by factor 4, not negative 4. The negative is there, but we're going to talk about the negative in a second. That does something else. You never ever refer to a compression or a stretch with a negative. Okay? A compression or a stretch is never negative, or it's always a positive number. So it is a VS, BAFO4. Okay, let me fix that. By a factor of 4. But no, yes, question. No? But no, go ahead. Does that say down 1? It does say down 1, yes. It's in Kamuk speak, okay? All right. Yeah. Sorry, go ahead. Yeah. On the reflection on the x-axis. Yep. Because it's in front of the whole function. If it was just in front of the x, then it would be reflection on the y. But negative on the outside is a reflection on the x. You can look back at your notes. That should be there, hopefully there somewhere. So reflection on the x. X-axis. Okay, so those are all my transformations. Okay? So let's focus on domain. Oh, by the way, I should put a little thing in red beside each of these to say what's x, what's y. And get some help. Krisha, help me out, please. Give me what the VT and the HT are going to affect. The VT affects the what? VT affects the y. How about the HT? Good. How about the VS? Let me go to okay. Wanya, what about the VS? What is that affecting? Affects the y, yeah. And actually, give me what the reflection on the x-axis. it also affects the y. So we have three things affecting the y. Looks like the range is going to be affected. Let's see now. How about the domain? Is the domain going to be affected? Well, the domain used to be XCR. Generally, that's never going to be affected. Generally, right? If it's all real, it's unrestricted. It's just going to stay unrestricted. That's what I'm trying to get across to you. So I'm going to say that for my range, sorry, to my domain, only one thing affects the x, and that's the right 5. That doesn't change my domain, right? So my domain, the resulting domain is still XCR. Let's get to let's get to the range now. So this says reflection on the reflection on the x-axis, down 1, and this thing here, vertical stretch by a factor of 4. So what are we going to do with our y used to be, here's what our y used to be. Our y used to be this. Y is greater than or equal to 0. What are we going to do with those y's, right? What are these various things that are going to affect the y suggest that we're going to do to those y's? Go ahead, please. You're going to flip the sign first, right? So rather than y being greater than 0, it's now less than 0, less than or equal to 0. What else are we going to do to it after that? Go ahead, Gary. Multiply by 4. And then what are we going to do after that? Yes. Then we're going to subtract the 1. So what are we going to left with? Y is less than or equal to minus 1. That's what we're left with. By the way, what are I do? Oh, this is your range. Sorry, folks. This is the range. Let me write this on the side here. Range. You know what? I'm going to move all of this over, actually. Let me move this all over. I did. Because it was y was greater than 0 before. It's now y is less than 0. Okay. Move this whole thing over. Move it down, actually. And then I can delete that. And I'm going to write range on top of that. So this part is the range. So the range finally works out to be this, that y is less than or equal to 0. So y is less than or equal to 1 with YER. So it's any real number as long as you're less than 1. Less than minus 1, sorry. Less than minus 1. Okay. I'm going to move along. See how much time. We're at 11:01. I'm going to see if I can get through some of the next question. Give you a couple of minutes. Like I said, I really want to get through all of these problem set questions today. So I may not be able to give you any time to finish your group project. It will be due on Monday, though, so you don't have to worry about that. Not giving any additional homework this weekend, except to study for the test, obviously. All right? Okay, let's move this along. So they give you a function, domain, and range. They didn't tell what the function was. They didn't say here's a function. They said here is the domain and range. I'm giving you the domain and range. You got it. Then they say, give me the domain and range if you take that function and do stuff with it. In this case, multiply by 2. The whole function by 2. So we don't have the function itself. All we have is its domain and range. I'm repeating myself. But we do know that we took that function that we had and multiplied it by 2. My first question is, for Nakib, what have we done to that function by virtue of this saying y is equal to 2fx? Correct. We did a VS, BAFO 2. True. Which, by the way, let me stick with Nakib on this, affects what again? The y's. So, we've partially answered the question. If my domain used to be this, and I'm doing a vertical stretch, what's going to happen to my domain? What's going to happen to my domain with this vertical stretch by a factor of 2? You want to say what, Suchir? It's not going to change, right? This thing affects the y. Domain is the x. It's not going to change. So my domain is still whatever it was before. X is greater than or equal to minus 4, XCR. No change there. How about the range? Well, the range used to be that y is less than, but not equal to, by the way, less than minus 1. What do you think happens to that range? Okay, AJ. Can't hear you. You times the range by 2. Absolutely. So what does that make the range become then? So if he's right, then maybe I can ask somebody, say what the actual range is going to be then. Sano, how about you? He just said he just times the original domain by 2. What is the domain going to become then if I just times it by 2? Go ahead. Sano? It's not equals, it's less than. Less than negative 2. There you go. That's my range. You notice that I'm not writing all these wing brackets and the y with the long. I mean, that's window dressing for me. Other teachers might insist on that. I don't really care. So my range is y is less than, but not equal to, minus 2. We just did exactly what AJ said. Multiply the original range by 2. Done. Right? Okay, next question. B. It's the same domain and range, but, sorry, yes, Shamin. Did I really? I did. I did. I guess when I start taking off marks for this, you're going to remind me that I wasn't doing it. That's what you're going to tell me. I know you're going to tell me that. Right. Okay. All right. Yeah. I guess that I deserve that. Okay. Thank you for pointing that out, though. I appreciate that. Let's move on. 3 f of x plus 1 plus 4. So, my first question is, give me a list. Give me a list of the transformations that are going on with this. Angela, I'm going to need your help. Give me some transformations related to what you're seeing on the board right now. Give me at least 2. Up 1. Okay, so VT up 1. Give me one more. Up 1. Hold on. Whoa. You said up 1? That's not right. Okay, no, that's not. But it's a VT. We're talking about, you said VT, right? So that's still not right. Let me get some help for you on this one. Okay, Shreyash. VT up 4. Yeah. We're going to come back to you, though, Angeli. We have to come back to you. Let me fix this. Do you see why it's a VT is up by 4? Do you see that? That makes sense? Okay, good. Give me another one, though. We're going to have to redeem yourself. Give me another one. Good. HG left 1. All right. And there's one other thing going on. Go ahead, Abel. VS BAFO 3. Okay. Now, check out your original domain and range. And let's see if we can come up with a new domain and range. Let me put beside each of these what it's affecting. Let's remind you now. Because that's going to help us figure out whether it's the domain is going to affect or the range is going to affect. The VT up by 4. Let me come in the front. Manahill, VT. What's that? The Y's, good. Give me one more. HT left 1. Good. And we'll just stick with you for the last one. Vs would be y. Okay, good. Okay. Now, I need some help. Let's start with, I usually do domain first. So, Emily, I need your help. The domain used to be x is greater than or equal to minus 4. According to what we just heard from Anna Hill, she said only one thing affects the x, and that's the horizontal translation left by 1. So how do you think that's going to affect your domain? Because the domain is the x's, correct? Okay. What do you think I'm going to do with the original domain, which used to be x is greater than or equal to minus 4? How is that going to be affected? What's that? Okay, give me the new domain then. Negative 5. So x is still greater than or equal to. So domain is now x is greater than or equal to minus 5. Yes, before it's pointed out, all real numbers. Are we good? Athuzan? Sahil? Nakib? Okay. The range. We'll take a break after we do the next one. The range. The range. Let me go in the back. Thank you for offering. Let me go in the back to Hashim now. Hashim, when people don't put their hands up, at some point they're going to get their names called. So Hashim, when I asked a question earlier on about the things that affected the y, Manahill said it was the VT up by 4 and the vertical stretch by a factor of 3. That's what she told me. And I agreed with her, by the way. So now we get to the range, which is the y's. Tell me what's going to happen to my range. Help me out with the range, please. The range used to be y is less than minus 1. What am I going to do with that? Good. Good. Excellent. So do it. Tell us what the result is. Here's my original range. Y is less than minus 1. So do what you just said. Multiply by 4 and then add rewind. Multiply by 3, sorry, and then add 4. Okay. Yeah. You started off as y is less than minus 1. So do what you just told me. Multiply by 3, then add 4. Yeah. Sorry? No, 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 no. Let's do it in stages. So it used to be 1, sorry, minus 1. We're going to multiply that by 3, we said, right? And then we're going to, not negative 3. We said by a factor of 3, so it's just positive 3. Oh, and then we're going to up 4, right? Plus 4, correct? Okay, so what's that? What is that going to be? I hope you're not using a calculator. What's the answer? 1? Good. Y is less than 1, but YER. So that's what happened to our range, right? You multiply by the 3, like you said, perfectly correct. Then you add the 4. So now our range is now this. All right, like I said, we're going to try and squeeze one more in and give you a couple of minutes. All right? This is done. Uh-oh. Uh-oh. Yeah, question? Yep. Okay, can I move on now? All right. This one. What's going on here? I need some help from you here, please. What's going on here? What does that suggest is going on? Nothing for this? This is not changing it at all in any way. No. All right. I'm gonna have to disagree with that. Go ahead. Reflection on the x-axis. I'm gonna have to disagree with that as well. Yes. Reflection on the y-axis. Correct. What does this affect though? Yes, Wanya. It affects the x. It actually affects the x. Okay, so can we agree that the range is not going to be affected here? Because the range is y's, right? So we don't have anything to do with the y's. The y's are going to be what they are. We don't want to have any. That's going to just be what it is. But what about the x? What about the range? Sorry. What about the domain? Let me go to the front. Thanks, Rafi. Your time. What's happened? What happens? What happens now? Switch the signs. What do you mean by tell me what you mean? Expand on that. But we're focusing on the x's, remember? Right? We're talking about the domain now. The range we are just saying is not going to be affected, right? Remember we just said that? Okay, so tell me what's going to happen to this domain. That's what I'm trying to ask you. Based on the fact that, as we just heard, right, from the front here, Athuzan, I think it was who told us, there is a reflection on the y-axis, which affects the x, which is our domain. Okay? So tell me what's happening here. What are we going to do with the domain? Okay, I'm only asking one person right now, please. Thank you very much. Go ahead. You flip the sign. Give me, spell that out. What do I write? Y is less than negative, greater than negative one. No, I'm not happy with that answer still. Not happy with that answer. Abel. Okay, how? Say it again. But that's what it is now. The domain is that x is greater than or equal to negative 4. So x is less than or equal to? Still don't agree. Still don't agree. Go for it. To 4. Because all the x's get multiplied by minus 1. And when you multiply a minus 4 by a minus 1, it becomes positive. Are we good? I mean, no? No, we're not good. You're right. You're absolutely right. Yes, you're absolutely right about that one. I got caught so many times on that one. Is there something I need to do with this before I go any further? Can you see anything that might make this a little easier to figure out by rewriting it a little bit? I'm kind of hinting at something here. Factoring out the negative, yes. So let's do that. Let's do that. So I'm going to rewrite this as minus 2 f of. So I'm going to put minus here. And then what am I going to put it inside the bracket now? X minus 5. And then we still have the plus 1 on the outside. Okay, that's the same as what we had before. We just factored out the minus 1. That's all. All right, good job, Krisha. So I need that list now. Shreyash has some parts of the list. Shreyash, go ahead, Shreyash. Reflection on the y-axis. I agree. Lots of stuff going on here. Reflection on the y. That's one. Something else is going on. Manhill. Reflection on the x-axis. Okay, there's a lot more going on here. Latifa. And I like the way you said it this time. VS by a factor of 2. What else? Abel. Yep. For HT right 5. Let's see if I have everything. No, there's one more thing. Masumi, VT up 1. And I'm going to acknowledge Ashton's hand as well. VT up 1. Okay. I think we got everything. Two reflections, translation. Yeah, I think we got everything. 5 things going on. All right. Let me list again what each thing affects because that's important. I'll put that in a different color. Put that in maybe purple. So let's go down the list. Go ahead, AJ. The first one, reflection on the Y affects the X. Okay, give me something else now. Go ahead, go ahead, Wanya. Next one affects the Y. Go ahead, Masumi. Vertical stretch affects the Y. The HT affects the X, and the VT affects the Y. Good stuff. Good stuff. So 5 things are going on. Let's focus on the domain, which is all the X's. So it would be this, this that affects the X. Those 2 things affect the X. So we need to ask ourselves how, because we're talking domain now. So let me go down and write domain. This is the domain that we're talking about. It goes right 5 and it's reflected on the y-axis. I'd like to see somebody tell me what that answer is going. What are we going to do with the original domain? The original domain used to be x is greater than or equal to -4. What's happening with that is the question. Let me come into the front of the room now. Go ahead, Sahil. Domain, yes. Look at you. Look at you. 5 plus 4 is 9, yes. So my domain used to be, where is it now? X is greater than or equal to 4. X is greater than or equal to, -4. To -4. So he says we're going to multiply that by, because remember, X is reflection on the Y. So we're going to multiply this by -1. Right? And he also made the point that we have to add to that the 5. Right? So, and the other thing that he mentioned is that instead of being X is greater, it's going to be X is less than. And then the 4 times -1 is going to be 5. 4 times -1 is 4 plus 5 is 9. So X is less than or equal to 9. Did we leave anybody out on that one? Is everybody clear on that? It changes the direction of the inequality. So it's now less than. This thing that used to be minus is now positive. And then we add the 5 onto that, which gives us less than 9. It's still wrong? Yes, it is still not complete. I wouldn't say it's wrong. It's not complete. Okay? Not wrong, but not complete. Okay, good, 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 good. Keeping Mr. Kamak on his toes. I like that. Okay, let's get range now. 3 things are going on with the range. Let me put a different color for that. So that's this, this, and this. I'll put that range in green to sort of color code it. So the range is what we're talking about now. So who is going to be brave and step up and say, I got this, Mr. Camp. Oh, look at that. Ashton. Go for it, Ashton. Let me go back and show you what the original range was first. The range used to be that. Go ahead. Rise great. Oh, that's you just give me the final answer. Says y is greater than 3. Okay, let's see. So it's less than now. Multiply that so you get +1. And then, what are we doing with that again? We are Well, let's see now. Reflection. Okay, we got that. By a factor of 2. So multiply by 2 and then up 1. So no argument with you, sir. But let's just do it in stages. Y used to be less than minus 1. So you multiply that by minus 1. And then you multiply that by, you could just multiply by minus 2 actually, but let's multiply by minus 1. We're going to multiply that by 2 because of the vertical stretch. Then we're going to add 1. So that would be positive 2 plus 1, which is 3. So I'm going to change this to, it's not less than or equal to, by the way, it's just less than. So let me change that. And then, so he's going to make it y is greater than, because it used to be less than, yeah, greater than 3. All right, so this multiplies those, gives us 2 plus 1 is 3. Y is greater than 3. Okay, you're not going to catch me on the next one. I promise you that. Not going to catch me again. Y is greater than, no, I'm not. Okay. Let me make sure I don't do that next. Okay. Guys raising the stakes on me. Maybe putting money on the table. All right. Okay. So good job, by the way, Ashton. Good job. Y is greater than 3. Okay. I think there's another one. Let's see. There's 2 more. Okay. There are 2 more. Reflection on the X? Yes, good. So reflection on X. What else? Look at you. Exactly correct. Horizontal compression by 1/4. Why is it 1/4? It's the reciprocal of that 4. So what's happening is that the numbers are going to, it's like dividing by 4, basically. Just like dividing by 4. Okay, so before we go any further, let me hear what this affects. That's the question that we need to answer. All right, what is this going to affect? So let me see what Sahil thinks. Reflection on the X is going to affect the what? Correct. How about the horizontal compression? Is going to affect the X. So one affects the Y, one affects the X. Absolutely correct. Latifa, let's get to the domain now. Now, according to what we were told, it's a horizontal compression by a factor of 1/4. We're either multiplying by 1/4 or we're dividing by 4 because it means the same thing. Okay? It is. Does that make sense? Dividing by 4, multiplying by 1/4 gives us the same result. All right? So look at your domain of what it used to be and tell what my domain is going to be now. Domain would be what? No. No. You're dividing by 4, yes. Multiplying by 1/4, just so you understand this, a BLFO by a 1/4 means you're multiplying by 1/4, and multiplying by 1/4 means dividing by 4. It's the same thing. -1. There you go. There's your domain, and it's all real numbers. Okay? So as long as x is greater than -1 and it's all real numbers, you're good. Let's get to the range now. Does that make sense, everybody? Before I go any further, are we good? All right, let's get to the range now. So that's the domain. Here comes the range. What happens with the range is the question. And it looks like Amira has an answer for us. Go ahead, Amira. Y is greater than 1, you said? Excellent. And it's not greater than or equal to because it didn't say that. So it's just greater than 1. Okay, after the reflection. Well done. And thanks for all the hands that went up. Yes, Masumi. Would any transformations give us y equals all real number? Why? Yes, a lot of them did. I mean, the first, like when it was a straight line or when there was a cubic function, it was still yer at the end. Oh, if it's okay. Oh, I see what you're saying now. No, it's just that xer. If it's xer, if it was unrestricted domain or unrestricted range, and it's not going to change. Okay, it doesn't change because you're doing any transformations to it. I get the question. That's a very good question. Okay, one more of these, and then we're going to move on. Ooh, that's interesting. What does this mean again? What does that symbol mean again? Manahill? Inverse. So, what are we going to do with this? What are we going to do with this? What is the domain and what's the range? If I'm looking at the inverse function, what's the domain? Take out the thing for me. Tell me the answer now. He's right. What do you mean, what? Of course he's right. Of course he's right.
Oh yeah.
Yeah. Ah, okay. Right? Speaking truth over there. All right? So if he's giving you the range as a domain, that should tell you what the range is then. Right? You want to help us out with that, please? Sana? Correct. It's actually y though, because it's a range. Okay? So we're going to switch things up, turn things around. Here's my domain. It is what the range used to be. It's x is less than, but not equal to, minus 1, xer. And my range is what the domain used to be. Y is greater than or equal to minus 4, yer. Domain becomes the range, and the range becomes the domain. It is that simple. If you get this on the test, it is a gift. Depends on how generous I feel. I don't know yet. We'll find out. All right. We'll see. We'll see. We'll see on Tuesday. All right. I think that was the last one for this number 4. Let's see what number 5 looks like. It should be easier for you now. Now that we've done what we just did, this should be easier for you. We're giving you a function, and give you the actual function. It's that. Determine the zeros of the following functions. All right. So the original function is given to you in factored form, which really helps when you're trying to find zeros. Right, Abel? If I'm trying to find zeros and I get in factored form, I'm almost given the zeros right away. Isn't that true, Aaron? Okay, good. So that means we can answer the first question right now. The original function is just simply y equals f of x. So that's what a is. What are the zeros right now? What are the current zeros right now? Anjali, help me out, please. What are the zeros right now? Those are the zeros right there. Right? So the zeros for the first one the zeros, original zeros, are at 4 and minus 3. That's where my zeros are. That's my starting point. But what if I did this to the function? Right? Instead of the function that I started off with, I'm now doing this. Minus a half of times the x. Yes. Look at this. Set it equal to 0. It's like the zero product law right there. So it's original function. We haven't done anything to it. This one, we're going to do something to it. This one is the original function. So those are your 2 zeros. Okay. Are we listening over here? All right, so we can text later on. All right, we can do that later. So my question now is, all right, so that's for the original, but now we're gonna do stuff to it. By the way, what stuff? Tell me what stuff is going on, Aaron. Go ahead, Aaron. Say it again. Horizontal stretch by a factor of 2. Well done. HSBAFO2. Something else is happening though. Something else is going on. Something else is going on. Go ahead, Suchir. Reflection on the Y. Reflection. Spell reflection. Reflection on Y. Now, if we're talking zeros, those are all x values, right? The zeros are x values. So would these things affect the zeros? Right? A horizontal stretch, is that going to affect the zeros? Zeros are x's. Does a reflection on the y affect the zeros? Yes, it does. Yes, go ahead. Because we multiplied something directly by, if this half was in the front of the function, it would be a reflection on the x. But if it's attached to the x, it's a reflection on the y. It affects the x though, but it's a reflection on the y. Okay? So the question still is, do both of these affect the zeros? My answer to the question is yes, they do. Yes, they do. If it was affecting the y's, I'd say we don't have anything to do here. The zeros are still the same. But the zeros are both x's. So it will affect your answer. What does the horizontal stretch do? According to what Aaron just said, it says we're going to multiply by 2. Reflection on the y also affects the x. It makes it change sign. So what's going to happen to these two zeros is the question. Does anybody have an answer for that? Latifa? Okay. Round of applause there. Round of applause there. What Latifa just did is she multiplied both of these by -2, is basically what she did. She combined the reflection, which is a negative, along with the stretch into a -2 and multiply both by -2. So the zeros in this case would now be at 4 times -2 and -3 times -2, which gives us -8 and 6. That's where your zeros are now. Yes, AJ. Okay. Why do I have to multiply by? Okay. Take out the headphones for me first, please, so we can talk. This you I hopefully agree with the fact that there is a horizontal stretch by a factor of 2. That makes sense, right? There's a reflection on the y. Does that also make sense? Both of those affect my x's. Horizontal is an x. Reflection on the y affects the x. This one requires us to multiply by 2. This one requires us to multiply by -1. Just combine the two of them into 1. Make them both at the same time by multiplying by -2. Yeah, the original zeros were at 4 and -3. So she multiplied the 4 and the -3 by the -2. Okay, those were the original zeros. All right, good. Great stuff. Let's move on. Let's move on. -2 f of x. This one here. First of all, Abdullah, what's going on with the -2 f of x? Tell me what kind of transformations are going on there. Give me the nature of these transformations if I'm multiplying the f of x by -2. What does that do? I don't agree with that. Sorry. Don't agree with that. He said horizontal stretch by a factor of 2, but I don't agree with that. Let's give him a chance. Thanks. Try again. I'm putting the 2 in front of the whole function. Say the whole thing out. Vertical stretch by a factor of 2. What else is going on? Go, Sahil. Reflection on the X. Okay. Now, which of these is going to affect our zeros? Which one will affect our zeros? Go ahead, Sana. Say it again. Neither of. So you see, so you're trying to tell me that none of these are going to affect the X, the X, the zeros. That's what you're trying to say. Does that sound right to you? I'm trying to push you, but sometimes you have to push back and say, yes, Mr. Kamok, I was right the first time. Don't try to shake me off my answer because you're right. Okay? What's that? They both affect the Y, which doesn't affect your zeros. Okay, your zeros are X values. You see what I'm saying? So next time you stand firm. All right? If I say, you're sure about that? Think about it first. Yeah. Don't just don't just backtrack. Think about it first. And if you're sure, just say yes. That's what I'm saying. And I do that. Right? Am I being mean? Maybe. But that's my job sometimes to be mean. Right? Just to get you to rethink sometimes. And hopefully, if you're right, then just say, yeah, that's what I'm saying. So the answer to this question is that the zeros are what they were in the first place. Zero, oh, geez, that's terrible. That's horrible. That's really bad. Zeros remain 4, 0, and minus 3, 0. We're not changing our x's at all. Our x's remain where they were. Okay, I'm going to push some other people now and see what happens. Let's see what happens. Let's see what happens. Anjali, your time. What's going on here? Horizontal stretch. If I were to stretch something by a factor of 1, though, it's not going to change it, right? Multiplying by 1 doesn't change anything. You know what I mean? Are we going to go with reflection on the y-axis? I want you to think about that. I'm not saying you're wrong, but I want you to think about that. Consider where that minus is. Is a reflection? Is it on the y, though? That's what I want to make sure we're clear on. What do you think? Is it on the y? Okay, then. Okay, then. I like that. Reflection on the y. Which will affect the x, by the way, just so we're clear on that. What else is going on? Let me come in the front of the room now, next area there. What else is going on? Apart from the reflection on the y, which affects the x, by the way. For D. Nice. HT left 1. HT left 1. All right, I'll take a volunteer on this. Who thinks they can tell me the answer for what happens to the zeros that used to be at 4 and minus 3? That's where they used to be. Where are they going to go after this reflection in the y and an HT to the left by 1 that we just got from those two people? Atifa? Negative. You're right about the first one. Now, I have to think about the second one for a second here. So minus 4, minus 1, minus 5. Yeah, you're right. So minus 5, 0. And you said, what was the second one you said? 2. So that's positive 3 minus 1. It is 2. Yeah. I had to stop and think about that for a little bit. Let me tell you how she got that. If you haven't figured it out yet. Change the sign on the x's, then minus 1. So this x became minus 4, then minus 1 is minus 5. This became positive 3, then minus 1, which is 2. That's it. That's it. As usual, stop me if you need me to. Okay. So we finished that question. Now let's get to number 6. I think you could all do this one on your own, but I'm going to work it through with you anyway. The 0.14 is on the graph. They don't give you the graph. They just tell you that this point is on the graph, on the function rather. And then they say, they determine the coordinates of this. Let me scroll over so you can see what we're talking about here. Determine the coordinates of this point on the graph. So you do a bunch of stuff to it. This is essentially what you were doing for your exercise yesterday in groups. Taking a point and doing a bunch of stuff with it after you figured out what all the different transformations were. So we should be able to handle this quite easily. Well, we should be able to handle it. Let's see how easy it is. Gary, give me some of the transformations that you notice for this function. Give me all the stuff that you think is going on. Reflection on y. Give me one more. Gary, give me one more. Vt down 2. Good. There's more stuff going on. Shreyash, go. HT left 1. Yep. Okay, there's more. There's more. Go ahead, Aaron. HC, horizontal compression by a factor of 1/4. Good stuff. Got that from that 4 that was on the outside there. Anything else, Ashton? VS by a factor of 3. Is there anything else? No, that's it. So let's do our usual. This affects the X, this affects the Y. Let's do all of that. Put that in red. All right. Okay. Let's talk to Rosie now. Rosie, give me the first two. Number 1, reflection on the Y affects the. Thank you. VT down by 2 affects the. Nice. Nakib, HT left by 1 affects the. Good. Give me one more. HC by a factor of 1/4 affects the. Another X? Yeah. Another X again? Got him. I got him. I got him. It is X. Right? Because I challenge you doesn't mean you should change your answer. Okay? Don't get nervous. Right? Yeah, rethink it. Did I make a mistake? I made mistakes. So rethink it. But if you still got the same answer, then just say it. Okay? All right. All right. And then one more. The VS. What does that affect? Okay, I'm not even going to challenge you. I'm just going to put the Y down. Okay, so we have, what is it? 3 X's and 2 Y's. So let's pick this apart now. Let's focus on the X value first. The X value used to be 1. That's what it used to be. What do we do with that 1? I'll take a volunteer on that. What are we going to do with that 1? Right? Go ahead, Che. Turn to a negative, so it becomes -1. Yeah, then what? Divided by 4 or multiply by 1/4, same thing. And then subtract 1, you said? Okay, good. So we're going to focus on the x's. So this becomes a -1 multiplied. Okay, let's do this. Let's do it in stages here. We started off with 1. We're going to multiply that by -1. Then we're going to multiply that by 1 over 4. We're going to multiply by -1 over 4. And then we are going to -1 from that. Okay? All right? We took the 1, the original 1, multiplied by 1 over 4 because of the horizontal compression. And we change the sign. So really what we have here is -1 over 4 minus 1. And if we get a common denominator, I'm going to get -5 over 4. You can double check that for yourself. That's my new x value. Let's get to the y now. The y used to be 4. What's going to happen to this 4? I'll take a volunteer. What's going to happen to the 4? Okay, Atifa, go. Right? Multiply by 3, subtract 2. Absolutely. And it used to be a 4, so 3 times 4 is 12, and then 12, so that's 10. So it used to be 4. We're going to multiply it by 3 because of the vertical stretch, and then we're going to -2. So that's equal to 10. So here's our new point. -5 over 4 and 10. Yes? Yeah, that's fine. That's the same thing as 5 over 4. Yeah. So I'm okay with that. All right, I think we're making some progress here. All of those kind of relate, just looking at all the transformations that we had to do. All right, things change up a little bit now. Word problem. I'm going to take you back to your physics class for a bit. I'm assuming you've all done either physics or general science or some kind of science course. I don't know. There is a relationship between the following 3 things, between time, speed, and distance. Those 3 things are related. Does anybody know any equation that links those 3 things together? Speed, time, and distance that you learn in, I'm going to assume in physics. Go. Speed is equal to distance over time, he says. Let me write that down. Speed or rate, I'm going to use R for rate, which is the same thing as speed, right? Rate is equal to distance over time. Is that what you're saying? Well, if you're traveling along the highway, as you all have at some point, along the 401 or whatever highway, you see signs posted along the side of the road that say speed limit of 100 kilometers per hour. That's what the usual thing is. What they're doing is they're dividing the distance, 100 kilometers, by the time of an hour. So yes, that's how speed is measured. You can get speed by dividing rate, speed, same thing. You can get speed by dividing distance by time, but I can rearrange this, and let me just sort of write what each of these things here. Rate is the speed. D is the distance. D is distance. Let me fix that. No, yeah, I'm doing it right. This, what am I doing? Rate is, R is speed. That's what I'm trying to say here. The R represents the speed or rate. The D is the distance. I just want to make sure you understand what each thing represents. One second. Oh, all right. I'll just erase it. The D goes for distance. And the T stands for time. Now, you could measure these in different units. Speed is, in our context, usually in kilometers per hour. If you're in America, then it would be miles per hour. They measure things in imperial units. We tend to do it in metric units. But it's still the same relationship. But Having said that, there are two other ways that we could write this. We could write it that time is equal to distance divided by speed. And we could also write it as distance is equal to, what did I change it to S? I meant to be R. Let me change that back to R. Distance is equal to rate multiplied by time. So these three statements are all just different ways of expressing the same relationship. So we could get the time by dividing distance by the rate or the speed. We get the distance by multiplying the rate times the time. You get the rate by dividing the distance by the time. Okay, so all three things are, these are the relationships that exist. It's just a matter of rearranging algebraically. Okay, why am I going into all of this? I want you to look at what this is saying, that David is in a 65-kilometer dirt bike race. The first half of the race, or 32 and a half kilometers, he rides at an average speed of 16 kilometers per hour slower than in the first half. Okay? So his speed is going to be slower in the second half than it was in the first half. He got tired. Okay? So 16 kilometers per hour slower than in the first half. Let X represents David's speed in the first half. So there's a let statement there. And I'll write that down. I'll repeat what the question is saying. So let X equal speed in the first half. So what would his speed in the second half be then? If X represents the speed in the first half and he's going 16 kilometers per hour slower, go ahead, please. No, it's not quite right, yeah? X minus 16. So speed in the second half, since it's 16 kilometers per hour slower, we just simply take away 16 from X. So X minus 16. Okay? 16 kilometers per hour slower. So I just thought I'd write that down because look at what they're asking us for. Determine a simplified expression in terms of X for the total time he took to complete the race. Yes. X times, not quite. I'm going to write two equations for time. Time in the first half, I'll put time in T1 and then time in the second half. I remind you that time, according to this equation here, is distance over speed. The distance, remember, in the first half, you're just doing in the first half of the race. The race is 65 kilometers. So first half of that is 32 and a half. You can divide 65 by 2. So 32.5 divided by his speed in the first half, which we call x. In the second half, it's the same 32.5, but we said that his speed in the second half, what you just told me, Sahil, was x minus 16. Where did I get 32.5 from? Anybody can help me out with that? Where did I get 32.5 from? Yes, Manuel. 65 divided by 2 because the whole race was 65 and it's divided into halves. The first half and the second half. So the distance is split in two for each part of this race, okay? Thanks for that question, by the way. So what is the total time taken? And that's what the question is asking us for. Determine a simplified expression in terms of x for the total time it took to complete the race. So this is the speed and this is the time for the first half. It's the time for the second half. Give me an equation for the total time that we're going to take. Yes. T1 plus T2. So the total time would just simply be taking these two things, adding together. 32.5 over x plus 32.5 over x minus 16. As easy as that. Right? This is T1, that's T2. And if you haven't figured it out yet, we're back with rational expressions because we have to add those two together. So how do we add these two together? How do we put two fractions together? Yes. We got to, thank you, Shreyash. We got to find that common denominator. And what is the common denominator in this case? Can anybody help me with that? What is the common denominator here? Common denominator between these. Anil, go ahead. No, people have forgotten how this whole common denominator thing works. One denominator is x, the other denominator is x minus 16. Go ahead, Masumi. You just do what? No, it wouldn't be just x. It would not be just x. Everybody forgotten how this works. Yes, go ahead. No, it's not. No, it's not. Yes. Thank you very much. You've all forgotten how this works. The easiest way to get the common denominator is multiply the two denominators together. Okay? Sometimes that's the only thing you can do. Sometimes that's the only thing you can do. Now, you might say, if I were to, expand, so I get x squared minus, but it would be minus 16x. So that's why it's not just x squared minus 16. Okay? And then we ask the question, yes. Yeah. What do you multiply this by? Let me point to it here. What do we multiply this by to get x into x minus 16? Yes. X minus 6, what to multiply the top by that? So 32.5 multiplied by x minus 16. Plus, what do we multiply? Let me move this over a bit. What do we multiply x minus 16 by to get x into x minus 16? Yes. X, will multiply the top by x plus 32.5x. So what we're going to do is we're going to multiply it out, simplify our like terms like we always do. So that is equal to 32.5x minus, okay, I need some help now. 32.5 times 16, 520 minus 520 plus 32.5x over x into x minus 16. So that, if we put our like terms together, would be 65x minus 520 over x into x minus 16. I'm not going to expand that denominator at all. I'm going to leave it as it is. Sometimes a good idea to see if you can factor the top. And if we did, there still wouldn't be anything else we could do with it. So I'm going to leave it as it is. This is our total time right here. So if I knew what x was, and x would be different things. X, remember, represented by the speed in the first half. That's what that was. If I knew what the speed was in the first half, I could easily figure out what the total time is by just plugging x into this. All right. Are you staying with us? Okay. Here is the question now that there are. So this is part A. I've done part A. Part A is done. Let's get to what they're asking in part B. So, okay, if David rode his bike at an average speed of 35 kilometers per hour in the second half, how long did it take him to finish the race? So do we just put 35 as x into the formula? What do you say? We have to add that, correct. This is in the second half. But x is not the speed in the second half. Yes. Mm, not really. They gave us a speed in the second half, right? Which is 35. That's what they said, right? That's what the question says. But the x that we have for this is the speed in the first half. So we can't just put 35 into the equation. We have to adjust that 35 to figure out what his speed is in the first half, which we were told is 16 kilometers per hour slower. So he must have been going faster in the first half. 16 kilometers per hour faster in the first half. So if in the second half he's doing 35 kilometers per hour, in the first half he must have been doing a faster speed. And you just said it, by the way. We just simply add the two together, right? Take the 35, 35 plus the 16, add those two together, right? So let's put that down. Speed in the first half, so that we know that the speed in the second half was 35. So that means that we now know speed in the first half would be equal to 35 plus 16. So we know his first half speed was 51 kilometers per hour. Can we agree on that, first of all? Yeah? No, this is the x that we're going to put in, because the x that we had in the equation was the speed in the first half. So now we can figure out the time, because we have an equation for time. So we're going to say that the total time using this formula is equal to 65 times 51 minus 520 divided by 51 into 51 minus 16, because that's what our equation says. Anywhere I had an x, I put 51. 65 times my x of 51 minus 520 over 51 into 51 minus 16. Okay, so let me get my final line. Okay, I need your help. I don't have my calculator here. 65 times 51 is what? 3,000. Okay, do this for me. Just minus 520 from that. Just give me the whole thing on top. Thank you. Zero. 2795 is what I'm getting. Is that correct? Okay, thank you. And then on the bottom would be 51 times, I guess 35. What's 51 times 35? 1,785. Okay. So what is the time that we're getting out of this then? What does that work out to be, Gary? How much, sorry? 1,000 for the time? 2795 divided by 1,785. What is that? 1.56. Let's just round it off. The question didn't say how to round it. I just put 1.6. 1.6. And what are we going to measure time in based on how they gave us? In hours, yeah, correct. 1.6 hours. All right. Yeah, I know that question took quite a bit of time. I know. Review it again. Go back and look at the video again. If you're not sure, come see me if you need to about that. The key here was getting the equation, right, for the combined time between the first and second half, and then figuring out what x you're going to put into the equation to figure it all out. All right. Let's see if we can motor through here. Get a couple more of these done. Some of this might spill over into Monday. That's why I had to postpone the test. Excuse me? Excuse me? You said something about Saturday? Is that what you said? No, that's you. No, that's my time and your time. We're not gonna mess with that. Number 8. Sorry, yes. I would actually prefer that. Yes. You said decimal or fraction? Oh, as a decimal? Yeah, decimal is fine. I don't mind fractions because they're much more accurate. So you could actually leave it as a fraction. Okay. Okay, let's see if we can get through at least 2 more before we wrap this up. Perimeter of each rectangle, state all restrictions on the variable. How do we find perimeter again? Yes. Yeah. Length plus width times 2, correct. Length plus width times 2. Or sometimes 2 lengths plus 2 widths added together. We can do that as well. So we're back with rational expressions, folks. That's where we are. So I'm going to take Shreyash's suggestion. We're going to add the 2 together, then multiply the whole result by 2. So here we go. Here's my perimeter. Equals 2 times 12x over 7x minus 2y plus 13y over 7x x minus 2y. Look familiar? Of course it should. So what's the next step? We're adding two fractions together. Just what we did a few minutes ago was adding fractions together, but we had to find a common denominator. Yeah, go ahead. Absolutely. Absolutely. Since we already had a common denominator, we're just adding the two numerators together. So it's 2 times 12x plus 13y all over 7x minus 2y. Right? That's it. And yes, we should multiply the 2 now. Should we multiply the 2 by the top and the bottom? What do you think? 2 by the top and the bottom? Does that make sense? Yes. Only by the top. Only by the top. So that should give us 24x plus 26y all over 7x minus 2y. That one was easy. That one was very easy. Okay? Not the top and the bottom. This is like multiplying by 2 over 1, which means I'm not multiplying the bottom by anything except 1, which doesn't change anything. That question is done. Luckily for us, it was already a common denominator. But how about the second one? Actually, it's the same. You know what? I think I'm going to skip this one. Yeah. Good question. Good question. Excellent question. State all restrictions on the variable. Anybody know what restrictions would be on this? Yes, go ahead. No, you could have zeros there. That's fine. Nope, nope, nope. Yes. You're on the right track. Let me show you what we're saying. We're saying that 7x minus 2y cannot be equal to cannot be equal to 0, right? Cannot be equal to 0. So what I would do is I'd say 7x cannot be equal to 2y. Or another way you could say is divide both sides by 2. You don't have to do this part, but probably not a bad idea. You could say that 7 over 2x cannot be equal to y. That's all it is. Just take set it equal to 0, rearrange it, and there's your restriction. Okay? So 7 to 2x cannot be equal to y. Thanks for reminding me about that. I want to skip the next one in the interest of time. It's something you should be able to do on your own. So I'm going to skip that one. This one is going to take us a little time. So take a deep breath. I'm going to give you 30 seconds to kind of just catch your breath before we tackle this one. Find the relationship between A and B. Actually, maybe I should I do this one or the other one first? Which one? Which one? You want to do this one first? Okay. All right. We only have about 10 minutes. All right. A and B have some kind of relationship based on this thing here. At the end of the day, we want to know what that relationship is. Is A equal to B? Is A twice B? If this is equal to this, then what is that relationship between A and B? What do you suggest we start? How do you suggest we start this? Any ideas? Okay, Che. Yep. Factor as much as you can. Factor as much as you can. So that stays as ax minus 1. But the bottom of this can be factored. Now here's where your magic x comes in. Take 2 minutes, no, take 1 minute and factor that denominator for me, please. I need 2 brackets. This is not a regular factoring. This is one where you need that magic X or factor by decomposition or whatever. Times, by the way. We're going to factor all the way to the end. Okay, but it sounds like Sujir has an answer. Excuse me. Hang on, Sujir. Hang on. Okay, Sujir, go. See, it's not as easy as that. It's not as easy as that. It has to be something x plus or minus. It's not as easy as that, right? No, it can't be that easy because of that 3 in the front. That's the thing that's mixed. That's kind of getting in the way here. Is my mic on? Is my mic on? Yes, sorry. Go, Che. That doesn't sound right, but I'm going to write it down anyway. 3x plus 6, and what's the other one? 3x minus 1. Okay, here's the problem though, Che. This and this don't multiply to give us the minus 2 on the end. So that's not going to work. All right, let me hear, excuse me. Oh, lots of coughing here. Let me hear what Abel has. Yes, Abel. Okay, let me write that down. So what I'm saying, folks, you got to learn how to do factoring like that. 3x minus 1, you said? And what's the other one? Okay, I'm going to test that out now. Minus 1 times 2 gives us a minus 2. That's good. 3x times 2 is 6x. Minus 1x is 5x. It's good. It's good. Well done. Please get some practice with that. Please. Yeah. I was just testing it out to see if it would work. You got to remember that you have to use that x thing that we talked about. Go back and look at that video if you need to. But I'm just testing it out. These two numbers still have to multiply to give me a minus 2, which it does. 3x times x is 3x. Sorry, I'm not saying that right. 3x times 2 is 6x. Minus 1 times x is minus 1x. So that's what's going to give me the 5x in the middle. Okay? Get some practice with that, though. That's important. Can we factor this? The x squared plus 2x. Can anybody help me with that? Can you factor the x squared plus 2x? Okay, Che, go. Good. Which leaves you with what? So x into x plus 2, right? Good. Okay, here comes another factoring thing, which is not as easy. So take your time, use the magic X, use decomposition, whatever you like. But I need 2 brackets now to make this magic happen. Take your time, folks. Go ahead. You should be able to do this on your own. Everybody should be trying this for themselves. Right? Don't wait for somebody else to give me an answer. Voice is kind of crapping out on me here. That's what happens when you talk for 2 hours. Can we factor 2x squared minus x minus 1? That's the question. You got to be able to do that for yourself. Right, Naomi? You're working on that, correct? Okay. Sana, you're trying to come up with something there, right? AJ, you're going to come up with your own factors there. Masumi, right? Anjali, Charmine, everybody trying this for themselves? Coming up with those 2 factors. Use Magic X if you need to. Okay. I see, excuse me. I see that Abel has an answer, but let's hear from you, Emily. Go ahead. 2x minus 1. Let me write that down. Oh, 3x minus 1. Are we talking about the 2x squared minus x minus 1? Here's the thing. The 2 numbers in front of the x here have to multiply to give us that 2x squared. So that wouldn't work. If you have a 3 and a 2, that's going to give you a 6. So that's not going to work. So try again. I appreciate you coming forward on that. Go ahead, please, Abdullah. What do you have? Let me write that down. 2x plus 1, he says. And x minus 1 is the other one. Okay, let's try this out now. This one and this one should give us the minus 1. 2 as minus 2 plus 1 gives us minus 1. Yeah, that's right. That's good. Good stuff. Okay, I'm going to write times now. Even though this says divide, I'm going to write times because we're going to flip the other one. Correct. So I'm going to put the bx squared at the bottom, but on top, yes, yes, you'll get minus 1, yeah, because it's going to be 2x times minus 1, which is minus 2x, and then the plus 1 times the 1 gives you plus 1, so that gives you the minus 1. There's minus 2 plus 1, which is minus 1. Yeah, because, okay, 2x times minus x gives us minus 2x. 1 times x gives us plus 1x. So it's minus 2 plus 1, which is minus x. Okay? All right. Let's see how we're doing for time. Not so good. Somebody needs to give me the factors of this now. 6. I know this is not as easy factoring. This is the harder factoring. The 6x squared plus x minus 2, that can be factored as well. Okay, in the interest of time, let me take it straight from Abel. Abel, go ahead, please. So he's saying 2x plus 1. And what's the other one? 3x minus 1. Let me test that out. Get the 6x squared from the front. I get minus 1 at there. 2 times the minus, so that's minus that. And then plus 3. Yeah, it's right. It's right. And all of that is equal to the 3 over x. Now, can we reduce this down? Can we get some stuff out of the way? Does anybody see any options for us to do that? Help me out. Manor Hill, please go ahead. 2x plus 1 and the 2x plus 1. Let's see if we can finish this up. Anything else that you see there? Go ahead, AJ. The x, sorry? The x minus 1 and the x minus 1. Yes. Anything else? Go, please. The 3x minus 1 and the 3x minus 1. Anything else? Yes. The x plus 2 and the x plus 2. Yes. Anything else? Yes. Go ahead, Aaron. The x, so this x goes to the x once, but there's an x squared here, so we're left with an x. Okay. Anything else that you see? Does anybody see anything else going on here? No? Okay, so let's see what's left over in the 2 minutes that we have left. On top, it sounds, let me go back to black. On top, it sounds like we have a times 1 times nothing else. So it's just a on top. I think that's all that's left. Yeah, okay. Over, what's left on the bottom here? Bx, right? And that is equal to 3 over x. I think. Let me just to make sure of that. A times 1 times da 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 da. That times that. Okay, times. Okay, fine. Now, can we do anything with this at all? Is there anything we can do with this? This over this is equal to that over that. Can we cross multiply maybe or something like that? Can we do that? Okay, we can. We can take the bottom of this side and multiply by the top of this side. So, and the same thing the other way. So ax is equal to 3bx, right? That's cross multiplication in a nutshell. Okay, I'm trying to sort of beat the clock here. But what do we do on the two sides of this now? Do you see anything we could do? Yes. Divide by x on the two sides. Absolutely. So what are we left with? 3b is equal to a, or a is equal to 3b. And we just beat the clock. So that's the relationship. That's the relationship between those two things, is that a is equal to 3b. Well done, class. We just beat the clock by a minute.